Okay, so we are still in the topography type of explanation. Alright, so let's continue on the topography again. But on this page, alright, I just want to better evaluate on this page. So if I were to zoom in a little bit, alright, this is actually the center line of your so this is your surface. Alright, then we say that there is a center line RA, correct? So this RA is the surface. We define the surface itself, the average surface lah. Okay, and that different way of processing. Let's say you saw the material, you'll give this type of um, surface roughness. If you use shaping, you'll give this type of surface roughness. Or if you use maybe grinding, for example, then you may have this type of surface roughness. So as you can see, the more, like say grinding, right, you'll get a more rougher surface, I should say. RA micrometer. Alright. Oh, okay. Smaller it should be. Yeah. So over here, this is the largest surface roughness, or the most rough. After you drill, after you mill, you have a very rough surface. But if you were to grind, if you were to horn polish, then you have a lesser roughness surface. Alright, for sand casting, you have also not a very good rough surface. Forming, you also not have a very good rough surface and things like that. So the different processes give you different rough surface. And the next one now is the topography of the surface. I mean, now come again. I don't know what I'm talking about. Anyway, so this is the graph. This is the surface. Alright, and we discussed the graph earlier in the previous video. Alright, this is the asperatus, the peak of your material, the peak of the surface, or over here the peak of individual's peak lah, I should say. So Z1, alright, is the vertical coordinates. Alright, so this is the Z1, and then Z2, Z3. So I think Z1 is this one, and then Z2, wow, good question. I forget where is it already. You give me a while. So over here, this is the graph in a more detailed way from the reading material. We can go to page 22, sorry. Yeah. So I plugged out this one. Alright, this blue color one is the RA. Alright, the one that determines where is your surface of your material. Over here, this is the minimum surface of your material. Yeah, I think. Okay. And the difference between them is X. Okay. And then Z1, up till now I don't even know what the hell is Z1, Z2, Z3, but there is this particular point. Alright, this is the center line, CL. Okay, maybe I should draw a green color line also. If I were to take a look, if I were to zoom in into the PPT slides, alright, so the Z1 is over here, alright, is where your RA line, alright, in the cross-sectional with the peak of this point. So when it touches here, this is where your Z1 comes in. Alright, and then the second time when it reaches here, this is your Z2. And then after that, if this is the RA max, I should say, this is the RA minimum, I think. Alright, so over here, this line also, when it hits here, this is called a Z3. Alright, and this is how they define the Z. Okay, but if you were to go into the slides that is given, the material one, if you take a look, it's a bit off already. Alright, so I don't know where is this point comes in and why is it over here. So I don't know how this graph comes about. Alright, so but nonetheless, this sounds more logical. Alright, so I think we just take this one rather than the reading materials. Okay, but nonetheless, since we know the Z1, Z2, Z3 already, where it intersects with all the RQ, alright, and all the RA, alright, then we will know that yeah, so we sum in on all the Z1, Z2, Z3, Z4, everything divided by the number of Z's. Alright, so this point where it intersect, this is Z4. Alright, then over here this point is Z5, and the next time it intersects over here is Z6, so on and so forth, all the way to Zn. Alright, so divided by the number of Z's that you're having, and then eventually you can get your values. Alright, so this is one way to get your RA. Okay, this is one way to get RA. So you find different z points, or then then this is where you can find your RA. But to a more exact, I don't know how exactly it works. Alright, but at least there are two methods. One method is using this equation, another one is using this one, root mean square. Same thing, you just take in the z wherever you eventually find this. Or nonetheless, you can find your RQ. So if you want to find RA, you use RA, RQ is RQ. RQ is root mean square. RA is your what's that called? Center line average. Okay. So center line average and root mean square average is the same thing. Alright. That's why I heard he say that both of them give you the same answer. Okay. So it's either you use RA or you use RQ. So I would think that, wow, then this means I'm wrong already. It means my this line over here is not RA. Alright, this line over here is also not RQ. Okay, so that's why I say it's wrong. Okay, so this line is just the upper limit, this line is just the lower limit. So it's just where this point is touching. Alright, and then eventually once you get already, eventually you sum them out all together, you calculate. Eventually you'll get RQ. Okay. So I think this is RQ. Alright, then this is RA. Alright, but yeah, this is the point where I kind of blur myself. But anyway, you just need to know all these things lah. I know my explanation sucks really, but okay, last two slides. Damn it, still got more slides to go. So over here, this thing over here is all your materials. Underneath are all your materials. Okay, and then over here, white in the white space is all your, it's just air lah. It's just air. Okay, so over here these are all your materials, including this one. Alright, these are all your materials. Okay, hopefully you are kind of clear of these are the materials. Okay, so this first graph, maybe I should say the first graph, this is the second graph. The first graph tells you the height. Alright, this is the height. Okay, and then it tells you the probability. This thing over here is probability, the x-axis is the probability. So the probability for this height is very low, right? So therefore it's very low if you were to go here. The probability is like 0.0 something. As you kind of go up, as you kind of come here, for example, reach here, you know that this point there is more probability now, right? So therefore the probability over here is higher than this particular point. I think you get what I mean. So the probability over here is higher than this probability because there is more points, more peaks. Alright, so as you go all the way up to this line, this particular your center line, that's what they call the RA. Okay, then these are a lot of materials, right? And therefore this is the peak, the most material part, and this is how they determine the surface of a material. So the most material that you can find along a certain line is your particular material, I mean surface. Also over here you will know that somewhat the center line is somewhere over here. Alright, and this determines your surface of your material. Alright, you can't determine the surface of material where it's at the peak, because it's just only this point that is there, but the rest aren't there, right? Because hope you get what I mean. It's just if this thing like that, right? Alright, you can't say that this thing over here is your average one. You can't say that this line is your length, is your average. You should say that this line over here is the average of your material surface. You know what I mean? Because this is way too high already, right? Then you can't use this point to say that this is the surface of my material. You have to have the average the most material at a particular surface, which is this surface. Then you will say that okay, this is my surface, and this surface is the surface of my material. So if I were to zoom out all the way, this is my material. So if I were to zoom in into this portion, this is what I'm looking. Alright, so this is the surface, and this surface is this thing. Okay, so this thing over here is just, maybe if I were to exaggerate a bit, it's like that. So talking about this is not your surface ma, this is just a spike only, that's all. Hopefully you are kind of clear, I guess. So this graph over here figure is talking about the amount of probability versus the height. Okay, Over here, this is the probability again, but it's versusing the amount of material. So over here, the amount of material is only this part up to all this stuff. Alright, as you go down at this particular point, there are actually more probabilities of this material. Right. So you think about it, the area under the curve lah. Alright, over here the area under the curve is very thin, just a thin layer. As you go down, maybe this is the area under the curve. So at this particular point, the area under the curve is very big because there's so many materials. There is so many materials lah. Okay. So at this point, at the depths of the some depths lah, maybe you can say that the lowest point. If I were to go all the way, give me a while. For example, if I have a material like this, alright, this is a surface, something like that. Maybe not, something like that. Okay, so this is the so-called the center line. Okay, the center line, and this graph over here is the x-axis is the probability, the y is the amount of materials. Alright, so over here the amount of materials that is our material. Alright, so this everything over here is our material, our surface lah. I mean our materials. And then the white color space over here, in the blue color one. Alright, these are all the environment. Alright, nothing that is regarding our particular material right now. Okay, so this is the surface of our material. Alright, so at this particular height over here, alright, actually not height lah, but at this the probability of material that is, give me a while, let me think about it. Okay, sorry, yeah. So the probability of the material at this particular height, the amount of material, total material I should say, at this height is how much? Very little, right? 0.0000 something percentage. Because it's at this particular point there is only very small amount of material as compared to this whole material, right? So therefore the probability over here is very small, 0 point something. That's why in the x-axis it's x-axis, right? This is x-axis. It's very small. And as you go down, so imagine you have this line lah. Okay, I kind of move around. So at this line, this is, maybe I should go, yeah. This is how it works, alright? So at this line, where's my pen like that? Okay, so at this line over here, it starts to go down. So over here, as you can see, if I were to go down over here, there are more materials now, right? At this particular points, there's more materials that is over here, right? So therefore it's trying to tell us that these are the amount of materials. Okay, so if I were to continue to go down, I use a different pen. Alright, if I continue to go down, I go, come over here, then this is the point. Alright, then I can continue to draw this thing. So this amount of materials are all these things. Okay, hopefully you're kind of clear. Right, all this thing that is above this line, these are the amount of probability of materials there are. Hopefully you're clear, right? And if I were to go all the way down, everything over here is all our materials already. Alright, it's really maximum, is way a lot already. Alright, so this is what it's trying to say in a very simple term, although my explanation is not exact yet. Okay, but at least you get to know the meaning of how the things works. Alright, and the graph that we have drawn, this graph over here, or this graph over here, is vary in shapes, and the distribution is dependent on the machining and the manufacturing process, and it goes all the way back to here, this page. Alright, where your different processings, alright, when you saw it, alright, you will have a certain surface roughness. When you drill it, you have a certain surface roughness also. So therefore, different processing methods will give you different topography of your surface, which are reflected in these graphs also. Okay, and the probability is using this equation, alright, and RQ is the root mean square. If you think about it, RQ is over here, okay, so you calculate your root mean square already, and then you can calculate your stuffs, okay. So this Z is talking about if you use Z1, what is the probability of Z1 happening. So if Z1 is over here, then you will know that at this particular Z1 line, how much material are being used. I think only lah, okay, nobody confirm lah. So yeah, so if you want to know Z1, how much Z1 is this, then you can calculate the probability at Z1, I think. But anyway, yeah lor. So last page, yeah, finally, so many things I didn't realize. So the next page, right, is actually the same thing as what we are saying earlier, but it's a different graph, okay. So imagine I have this line, so yeah, using this line explanation is really good, alright. So I have this red color line. At this point, the probability of material, the height, the probability of the material at this height is really 0, right? There's no probability at this height. It's very small, right? So the amount of materials at this height is also very, very little, okay. And as I go down, I use a different thing. As I go down over here at this height, maybe I should go down way more, alright. At this height, the probability of my material that is at this particular height, alright, is slightly higher already, right? Because the probability at this point, this is the probability, alright. The x-axis is the probability. Same thing over here. This x-axis is the bearing area ratio. So I think it's still the probability also lah. Okay. So at this height over here, this is the height, the probability of height of the material. So this is the height. This is the amount of material. So the amount of material is this path. Alright, and then the amount of what's that called? Amount of height is like amount of portion of the material at this height is this probability. Okay, hopefully you are clear. Alright, so it's a bit chim here and there, but it's not chim but rather than confusing. So yeah lor. So then the amount of materials as you goes down, alright, as you go down, as you go down all the way up to here, alright, as you can see, the amount of materials, the amount of height, alright, the amount of materials at this height, alright, is this amount, the probability at this height. So there is a lot of I shouldn't have highlighted this, alright, it's because it's particular at this height, alright, at this height, alright, this is the amount of material, and there is a lot of material that is at this height. So this will determine that this is the surface of a material. Alright, so I'll repeat again, this is the surface of a material. But nonetheless, this doesn't give you the full material yet. Alright, this is the composition of the material. It's still over here only. But because down there still have other materials, right? These are the other materials already. So these are the materials that they are talking about, and therefore they are talking about here. Hopefully you are kind of clear, right? So this is the bearing, talking about bearing, alright, talking about the shaft and the bearing, that of thing. So yeah lor. Therefore the key takeaway from these things that you should know is that the shape of the curve will give you a certain trend. It will give you a certain it will describe the surfaces, the type of surfaces you are looking at. Alright. So the different profile of the graph will give you different type of things. Alright. So therefore different shapes. For example, maybe we have something like that. Alright, then this will tell you that maybe this shape is for a triangular surface. Anyhow bomb one, okay. Then if you have this type of shape, then you will know, then you can see that okay, maybe this is like a circular shape. Alright, so at least when you see a different graph, you can see when you see a different trend of the graph, you will know what type of surface are you talking about. So it gives you a very quick gauge of the surface roughness of the material. Alright, So other measurements criteria are this all this stuffs lah. Alright, yeah, it's a really terrible video that I've made, but nonetheless I've cleared away only topography. Alright, its relation to surface roughness. The word bearing ratio curve, alright, is used to describe the surface. The shape can give some idea of the surface relatively to a purely. So the one that I've talked about it just now, right, the different shapes will tell you that maybe this is talking about this type of profile. Alright, this type of zigzag profile. Okay, if you have a certain, maybe this type of shape, then maybe your graph would look something like that. Then you'll know that, okay, maybe this is more on the curvy side. So this type of ratio curve is used to actually determine that. Okay, so I hope that this is also something for you to know. And therefore we are only here, and we have more to go. And I shall see you soon. Goodbye.